Welcome to Brain Vision.
Hi there. In this problem, we have a function g of the variables u and v, and we can also think of it as a function f. The variables x, and again, x depends on u and v, and so does y. Let's keep this in mind as we go through here because the variables can be tricky. So if we make a tree diagram, as in the book, we have f depends on variables x and y. And x and y each depend on the variables u and v. So let's use this to get our answer as we go. So first, we are asked to find g partial with respect to u at the point 0, 0. Now that means when u and v are 0, since u and v are the inputs for g. So to get this, let's use the tree diagram here. I want to get down to the variable u. So if we go down the left branch, we get f partial x, and then we multiply by x partial u, plus, let's go down the other side, f partial y times y partial u. And we want to evaluate this whole thing when u and v are both 0. Okay, so let's go carefully left to right and evaluate each of these. F of x, not f of x, f sub x here, f partial with respect to x. When u and v are both 0, we need to figure out what f's inputs are. In other words, when u and v are both 0, what is x? So let's look. And x, our first input for f, is defined as e to the u plus sine v. And so let's keep track of this. X equals e to the u plus sine v. And y, the second input, e to the u plus cosine v. So when u and v are both 0, let's write what x and y are so we don't get confused. X equals, well, we get e to the 0 plus sine 0. E to the 0 is 1, sine of 0 is 0, 1 plus 0 is 1. And y equals, let's see, e to the 0 plus cosine 0. So e to the 0 is 1, cosine 0 is also 1, 1 plus 1 is 2. So x and y are 2. This makes sense looking at the table they gave us. It pretty much had to be that, but it's always good to check. So now we know exactly where to look in the table for each of these. We want f sub x, and this is at the point where x and y are 1 and 2. So if we look in the table, we see that f partial x at 1, 2, that's the bottom row, would give us the number 2. And so that part gives us 2. Now x sub u comes next, and again x is given in the u and v variables, so this will be the top row of the table. And x sub u, I'm sorry, we actually don't need the table for this one. It's staring us right in the face. X sub u, let's calculate that right here. So x sub u, now here's our x over there. So the partial derivative of e to the u plus sine of v is e to the u, that's the derivative of e to the u, and sine v has no u's in it, so that's it. And again, at 0, 0, u is really just 0, so that will just be the number 1. Okay. Next up, f partial y. same thing as before. Let's look in the table. We care about the point 1, comma 2. So that will be the bottom row, and we see that's 5. So again, from the table, f partial y is 5. And y partial u, well, same thing as over here. Let's look. Y partial u is again e to the u. And when u and v are 0, this becomes this. So we get 2 times 1 plus 5 times 1. 2 plus 5 equals 7. So that's our first answer. Okay, the exact same idea now for g partial v at 0, comma 0. This time, we're just going to go down the tree diagram again. So we want to get down to the variable v this time, though. So we get f partial x times x partial v plus f partial y times y partial v. Once again, we are evaluating this at 0, comma 0 for u and v. And that means that our point x and y, again, is 1, 2. None of that changes. Okay, so let's use a combination of the table and their partial derivatives here. The first two that we got don't change. So that the red numbers up in our first problem here don't change. F partial x at this point is still 2, and for that matter, f partial y is still 5. None of that changes. What does change, we want x partial v. So let's look over here. The definition of x is e to the u plus sine v. So only the sine v will contribute to the partial v derivative. Derivative of sine v is cosine v. So cosine v, but remember at this point v equals 0. And finally, y partial v, let's look here. Same deal, e to the u plus cosine v. The derivative of that with respect to v is just a minus sine v. And again, v is 0. So we get, let's see, 2 times cosine 0 is 1. So this is 2. 5 times, well, sine of 0 is 0. So that will just be 0. And 2 is our final answer here. Hopefully this helped.